All right, good day, everyone. Welcome and thank you for joining today's webinar, Signal Performance Measures 201, Uses and Benefits. Before we get started, I'd like to quickly review a few housekeeping items. Everyone is muted and will be throughout the webinar. If you have questions during the webinar, please submit them through the GoToWebinar questions window. We will answer all questions at the end of the presentation. This webinar is being recorded and you will receive an email within 48 hours with a link to the recording. The recording will also be published in the INRIX resource library on our website. Now, without further ado, I'd like to turn the webinar over to Sean Quayle.
Thanks, Lynn, and hello, everyone. Thanks for spending a little bit of time with us. It's good morning for folks on the West Coast and good afternoon for folks here on the East Coast. We're going to talk through, just like Lynn said, the second installment of our webinar series on signal performance measures. Quick introduction for folks that are following along at home. So my name is Sean Quayle. I am public sector specialist here with INRIX. I've got 20 years of experience in consulting and on the public sector side with county traffic engineering, and I've been with INRIX for about 4 months now. Steve, you want to introduce yourself?
Yeah, I'm Steve Remius. I am the head of signal strategy, head of signals product strategy for INRIX here. I've got about 12 years of experience, come from an academic background, PhD from Purdue University, was a professor at Wayne State University before switching over to the private sector here. Ted?
Hi, everyone. So Ted Trepanier with INRIX. I've been with the company for 12 years working in our public sector services, and prior to joining INRIX, I was the Director of Traffic Operations at Washington State DOT, where I worked for 26 years. I worked signals all the way up from entry level, pushing buttons on the front of a controller, up to managing a statewide program. So a little bit of experience on the topic, and I'll be kind of moderating the questions today.
Excellent. Thanks for that introduction. I'm going to turn off my camera just to try to save some bandwidth. So agenda for today's session, we're going to go quickly through our recap of the 101 session, talk about kind of the overview of SPM benefits, comparison of the different sources of our SPM. So detector-based, you might hear it termed as AP SPMs. And then the GPS-based, trajectory-based SPMs, which is what INRIX Signal Analytics is. Talk a little bit about those SPMs in action, some use cases, conclusions, and then we'll preview our next installment that'll come along in September, SPM 301s. Hopefully everyone will stick around and we'll announce that topic here at the end. So let's go to our first poll question. Hopefully, Lynn, you've got that available for folks, and we'll go ahead and show that and get some feedback here on the big picture of your traffic signal program. So please go ahead and take a minute to respond. Your impression of the funding levels, the staffing levels, or other thoughts around the health and maturity of your traffic signal operations, maintenance, asset management, other things, anything that you could respond to related to keeping your traffic signals up and running well. Looks like we're getting a fair number of responses here. We've got almost 60% of the audience, which is at 67, 68 attendees right now. Looks like it's about 35% underfunded and understaffed, 30% well-funded and understaffed, only 15% saying well-funded and well-staffed, 5% at other, and 14% at underfunded and well-staffed. So good mix. This matches pretty closely with my experience while we were at Washington County, which was, we had, in a lot of cases, some pretty decent funding, but it was hard to find the staffing to deliver all the quality of some of the metrics that we're trying to do. So that's the end of the first poll question. We've got 3 more poll questions, so stay tuned for those. We're going to hop in and talk about what we covered at our last session, why are SPMs. So what we basically covered last time was an overview, getting everybody oriented, trying to raise the floor on signal performance measures. What are they? How do we define them? Things like split failures or percent arrival on green, Purdue coordination diagrams. We showed some examples of what that looks like, and you'll see a few more of those today. We talked big picture about how performance measures fit into your overall GHOST or goals, objectives, strategies, and tactics. We talked a little about some national surveys that have been done looking at how agencies were using the various signal performance measures that were available through the open source AT-SPM software that's started out through Utah DOT. A lot of those are progression, number of stops, arrival on green, travel time, split failures, with the application of trying to find detector problems. So we'll talk a little bit about those applications today with use cases. And they shared a little bit about experiences in Washington County and kind of the desire to get to signal performance measures, some of the complexities with getting detection in the ground and actually getting the software up and running, and then discovering some nice fits that I'll talk about later today with the GPS-based trajectory tool through the INRIX Signal Analytics platform. So kind of biggest picture, these are the two slides that stood out to me from our 101 session to really kind of summarize this, talking about the strengths and limitations of the two different sources of signal performance measures, the sensor-based, detector-based. You're going to get, as long as your detection's working, you're going to get all of the inputs for that 100% of traffic. It's going to give you information related to your actual signal timing. So splits, cycle lengths, offsets, all of that's going to be there. And there's some pretty robust visualizations that are built into that. The limitation is it's complicated. You've got to set up your channels, right? You've got to get your detector layouts correct. It can take some time as either a consultant or working with consultants or your designers to get the design process in place. There are a lot of points of failure because you're relying on hardware out in the field. And then some of the metrics, they are approximated. So you're not directly measuring something like delay, you're inferring delay based on detector actuations. Pivoting to the GPS trajectory-based model, which is what INRIX Signal Analytics is, the strengths are it's all observed traffic. So this is a true trajectory, sub 5-second iterations on those breadcrumb or waypoints that are coming through the system. You don't have to add any infrastructure, so it's simply that trajectory on a map. So it doesn't interface with your signal system, doesn't interface with detection or anything like that. Really easy to scale and look at consistent metrics across your system, so across corridors or across whole cities and counties, like we did in Washington County. And again, some nice visualizations for that integrated software, really easy to share with other folks. Limitations, it's only a sample of vehicles. You're not going to be able to directly see the signal state with something like a GPS-based trajectory model like INRIX or WeJo or something like that. It's vehicle only and it's not in real time, so you're getting the data on a lag. So that's kind of the overview of the 101 session. I'm going to touch on what kind of biggest picture, kind of if you walk away from this session wanting to summarize for your coworkers, what are the key benefits of SPMs? This is kind of the elevator pitch. Understand that reality system-wide. So we want to be able to understand the trends and events, what's meaningful, what's normal, what's not. And then ultimately, this should lead us to the better ability to scope treatments because we're using reality to make assessments about what's working and what's not working out in the field. This should allow us to use our time more wisely. So that previous question talked about whether we were understaffed or not. Well, if we're understaffed, we want to look for using and leveraging these tools like AT-SPMs or these GPS-based SPMs to help us focus our time on those biggest priorities, biggest issues. We can do relative comparisons. We can compare over time to an intersection or corridor, help us understand where we should be looking and getting at the heart of the issue. And then ultimately, the outcome we're looking for is better mobility and safety in our roadway system. But one of the side benefits of that is less trouble calls, less emails, less complaints. So if we can find and proactively address things, it's going to make it easier for us to find the issues, confirm those fixes worked, and again, be better focused with the resources that we have and the staffing that we have to tackle those issues that are right in front of us when we use these types of tools. Some use cases, you guys probably all seen these, thought through them, retiming signals, quantifying those impacts, talking about the Turismo strategies, you'll see some use cases. We'll talk about equipment failure and understanding the corridor performance. So again, use cases are a little bit different. It's how you use the data. The benefits were what we showed on that previous slide. So just as a quick teaser, a couple different applications that we saw at Washington County running the INRIX signal analytics platform, which is a GPS-based platform, and then marrying this up with some high-resolution video analytics data. In this case, is from Street Simplified, but looking at where we're having split failures, and then marrying that up with performance, looking at video analytics for what's contributing to, say, red light running patterns. And we see, I mean, it's not a scientific study, but a fairly high correlation based on our observations, where when we have split failures, it does tend to result in us incentivizing red light running. So whatever we can do to look at where we're having high split failures and see if that's normal or not normal, and then see if we can balance out the split failures is really important. And then the other piece to this is looking at gap acceptance. And there's a risk reward to allowing permissive left turns. We can move a lot more vehicles if we allow those permissive left turns. But if there aren't sufficient gaps, we can have some challenges with how this signal system is going to work, how safe the intersection is going to be. So we want to, as traffic engineers, find that right balance. And so the ATSPM software actually has a new left turn gap analysis that was developed by Georgia DOT. Thank you, Georgia DOT, for this. That measures the oncoming phases gaps in traffic, so that we as traffic engineers can look and see when do we tend to have enough gaps for left turners to make their movement, and when do we maybe not. And so ATSPMs can be useful at different scales, both in a trajectory perspective and from a detector perspective to answer different questions. And that's something you're going to hear Steve and I harp on through this, is these tools are complementary, and it's not one or the other in a lot of cases. You're going to find benefit from both. So let's switch over to poll question 2. Lynn, I don't know if you have that ready, but let's go ahead and pull that up and let's get some feedback on this. So what is your overall feeling towards signal performance measures? So let's kind of get a poll of our audience today as far as, are you excited and confident? Are you excited, but you got some reservations, you're still not sure, or still haven't done the due diligence to figure out what it takes to do that? Seen some good things, but maybe not all the way in, overwhelmed and don't know where to start, which is where we started at Washington County. Like, gosh, there's a lot of stuff to figure out with this. And then other, please put your response in the chat. So it looks like we've almost got, now we got 60% of the audience that have participated. And it looks like we got 84 folks on the call today. Thank you so much for taking some time with us. It looks like the majority right now, 48% are excited, but with some reservations. Coming up in second place in the poll, so with 20, and then a split 15% in excited and confident, overwhelmed and don't know where to start. So great feedback there. Let's move on to the next one, and I'm going to hand it off to Steve. So I'm going to stop showing my screen.
Awesome, thank you, Sean. Just to check, you can see my the presentation.
Yes.
Okay, beautiful. Thanks everyone for coming today for SBM 201. Looking forward to talk about some of the use cases and benefits of SBMs. One thing that I wanted to make sure that we discussed before we got into the use cases was some of the differences and comparison work that was done between detector-based SPMs and GPS-based SPMs. And so, fundamentally, at kind of the highest level, detector-based ATSPMs are dependent on detection, right? So pedestrian and vehicle detection at the intersection, and signal state information gets fed into the traffic controller and logged. Those internal data loggers get into a server, which then end up being put into some of these signal performance measure platforms, whether it's an open source or a private platform that folks can use to identify where they're having issues in their network. Pro-based or GPS-based SPMs are based on something a little bit different, right? So pro-based GPS-based SPMs are based on vehicle trajectory data. So we use we kind of leverage the highest frequency data or highest quality data that we can get from connected vehicles, and not in the sense of DSRC-based connected vehicles, but connected vehicles from the sense of they're providing GPS waypoints to the cloud. And so we take these GPS traces, some might call them a Hansel and Gretel breadcrumb trail of vehicles, as they're going through the network, and we log their experience or interaction that they have at the intersection. So if you look at this trajectory plot in the middle, this vehicle made its way to the intersection, stopped, and then kind of made its way through the intersection. So we can assume that this vehicle arrived on red because it had to experience a stop. And we're able to take all of those intersection experiences, whether they turned left, whether they turned right, whether they went through, whether they stopped at the intersection, whether they didn't stop at the intersection, how fast or how quickly they were moving or approaching the intersection, and log all of those things and display it into a platform. So the fundamental difference between detector-based and probe-based is the source of the vehicle information. And so as opposed to having a point sensor, the GPS-based system is really looking at the vehicle's full experience through the intersection. Another difference is there's no need for a connection to the controller or the cab. So the GPS-based systems are really independent of the infrastructure that's actually out on the field. So one question we get asked quite a bit is, how do these compare? How do we know it works? And so we actually did an analysis about a year ago that looked at comparing the detector-based ATSPM systems with the probe-based ATSPM systems. And we looked at a few different metrics, one of which being percent arrivals on green. And we used this to figure out what is that right stop speed and stop duration for a vehicle as it's approaching an intersection for us to say, yeah, it was considered a stop. And so we calibrated our stop speed. We use 6 miles per hour now, and we calibrated that to kind of represent or coincide with what was coming out of the detector-based system. Another metric that we looked at, percent arrivals on green down here, comparing what we were coming up with on the percent arrivals on green with the trajectory based and what these Purdue coordination diagrams were establishing. And we plus or minus 5%, depending on the intersection, is where we were. And I'll talk a little bit more about this later on. Another really cool thing was the split failures, right? So in the ATSPM system, there's the Purdue split failure diagram, which leverages red occupancy ratio and green occupancy ratio of a stop bar detector to understand where split failures occur. Obviously, a split failure is where a vehicle has to wait through more than one cycle to get through the intersection. And what we wanted to do was create a similar metric in our platform. And the way we did that was to figure out if a vehicle stopped twice. So if a vehicle stopped and then moved and then stopped again. So in order to do that comparison, and one of my, I think one of the cooler things that I get to show here is looking at a left turn in Utah based on the Utah ATSPM system and their Purdue Purdue split failure diagram. Anytime you see a yellow line here, it's representative that a split failure may have occurred. So in this left turn, you can see in this AM period, there's a significant amount of split failures on this roadway making this left turn. And so what does that look like if we start looking at trajectory information? What does that look like for trajectories making their way through that left turn at this intersection in Utah? And so this is any vehicle that stopped more than once in the platform. You can kind of start seeing, okay, these vehicles are making their way through, they're stopping, they move forward a little bit, they stop, they move forward a little bit, they stop. And this is really kind of representative of those split failures that you were seeing in the Purdue split failure diagram. In the same way, and a nice little experiment with the drop in volume as a result of pandemic, a few months later, April of 2020, we were able to do the same sort of representation, looking at the produced split failure diagram on this same left turn. There were nearly no split failures at this intersection, same intersection. And what did the corresponding trajectories look like? And so this is any vehicle that stopped once or more. And so what you really realize, and I got the side by side here, is when there's split failures, you can certainly see split failures occurring in the trajectory plots. And when you look at when there are not split failures occurring, you can certainly see that there are not split failures occurring in the trajectory plots, which is another kind of sanity check for us that the metrics that were created using the trajectory plots are valuable and compare pretty well to what we're seeing in the detector-based ATSPMs. Another question that we get asked often is related to sample size. So I have a few slides here to talk about the sample size and how you leverage the differences in sample size from an ATSPM or detector-based system with a trajectory-based system. And I'll point back to some work that was done at Purdue University by Chris and Darcy that kind of originally showed some of these trajectory-based detector replacements. So what they had done, and for folks that are aware of a Purdue coordination diagram, each dot on this plot represents a vehicle making its way through the intersection. And this is a single day. You can see a whole lot of dots. With the detector that was out at this intersection, they had nearly 100% of vehicles arriving in a single day. And any vehicle that arrives above this green line is arriving on green. Any vehicle that arrives below this green line is arriving on. So it's good when all of these dots are between the two lines. It's not so good from a coordination perspective when the dots are below the line. And so what's interesting about this is, so with 100% of vehicles, you can certainly see a trend of, okay, AM peak looks well timed or well coordinated. Midday, PM, evening look like there could be some work or some offset adjustments that they could benefit from. What the folks at Purdue did was then looked at a single day this is about 8 years ago, so the trajectory penetration has gotten far better, but they looked at a single day of just trajectory plots or trajectory points, virtual detectors that were making their way through the system. And you can kind of get the similar idea, but it's not as clear, right? You're taking a subsample of the information, and you can kind of see in the AM, look, we didn't observe any vehicles that were below this green line. So it looks like AM's pretty good. Midday is PM, not a lot of samples. Evening, well, not a lot of samples either. But what they did to overcome that was stack the data. And that's another thing that is a powerful tool that we have at our in our hands, is to actually stack the data. And so this is looking at 6 weeks of virtual detectors. And you can actually tell pretty much the same story, that when you're looking at the AM peak, it looks pretty well timed, well coordinated. When you get down to midday, PM, evening, it looks like there's some work that can be done. So in that kind of respect, we've gotten a lot of questions related to, what's your penetration rate? How many vehicles are you observing? How many vehicles do you need? And the answer really is it depends. It depends on a few different things, right? It depends on the variation of your data, meaning if you had 100 vehicles and every single vehicle took 5 minutes to get through a corridor, well, you would really only need one vehicle to represent that whole population size. If there's a large variation in travel times, you would need a little bit more of a sample. The other thing that's really critical is the acceptable margin of error. Are you trying to be plus or minus 2 miles per hour, or plus or minus 2%, 3%, 4%? How accurate are you trying to be able to draw meaningful conclusions? So essentially, as your standard deviation or as your variation goes down, and as your margin of error, your acceptable margin of error for whatever your use case or objective is, up or down. That'll adjust the sample size that you need in order to represent the population at an intersection through performance measures. And so to put that in kind of perspective, we can use that to figure out how long we need to stack data in order to really draw meaningful conclusions. And one thing that we had done last year was look at an example of a corridor in Austin, downtown Austin, and show that, hey, for these major movements where we have really good penetration and really good sample sizes, we're getting statistically significant samples in a single day. If you need to get additional numbers, you can start stacking. So we stack the week on top of each other and a month on top of each other to start getting to these significant samples to actually be able to use these data to kind of derive decisions and perform use cases. And I'm excited, Sean, I'll share some of these use cases with you later on today. So moral of the story with this section is we've done comparisons between the GPS-based ATS or the GPS-based SPMs and the detector-based ATSPMs, and certainly the trends align, and depending on your use case and your objectives, you may need to stack data. You may need to look at more than a single day, but you certainly can derive value. Like I said, Sean will share some use cases related to the SPM based here in just a minute. I do want to share, this is a section on just general benefits of SPM. So I do want to talk a little bit about benefits from detector-based ATSPM systems. I was part of a project in Michigan where we had 2 corridors as a pilot implementation. And what was interesting was in the processes of updating signal timing plans and updating the offsets on this corridor, one of the offsets was actually fat finger, or it was entered into the system wrong. And so one of the the powers of proactive signal management through SPMs is we were able to catch it. So we were able to look at the travel time of a vehicle through the system, and essentially when we put out a new offset ahead of the 4th of July holiday weekend, and we saw a significant bump in the travel time through the corridor. And had it sat there, we would have probably heard about it through a phone call or something. But we were able to actually identify it with the SPM information that we were looking at and fix it, and have a user delay value of $1,250 per week or $65,000 per day. So we were able to leverage the metrics, the ATSPM metrics, to actually figure out where we made some mistakes. And so what that looks like, and what's really nice about all of this is stories. Visual stories are really nice to tell, whether it's the public or an executive team or managers or even coworkers or colleagues. Hey, this is what happened. So you're looking at the Purdue coordination diagrams from after we made that offset adjustment, which you can see, as I explained earlier, a ton of vehicles arriving on red below this green line, to after, and I can do the eye doctor test here, but after we fixed the offset, we moved all of those points back up. So the before, tons of vehicles arriving on red, not exactly happy. After, tons of vehicles arriving on green, relatively happy in terms of progression through the system. Another really cool thing with ATSPMs, and I'm sure folks who have seen these before have probably, I love the offset optimization slides where you can look at Purdue coordination diagrams for every single intersection in both directions. So this is that same corridor when we did a massive offset optimization. And before, you can see, there's some of these intersections are performing really well. And then after, if you look at it, we've moved all of these points up to be arriving on green. So we improved the progression of this corridor. So there's a before, here's the after, the before and the after. And we quantified this benefit as $935,000 annual user cost benefit that was using some metrics from TTI. So these ATSPM systems certainly provide value both from a visual point of telling the story to identifying where you may have made a mistake or where there are opportunities to improve the system. So with that, and talking about the use cases for detector-based systems, I'll open it up, and Lynn, if you're still around, to poll question number 3. So poll question number 3 is really trying to find out where folks are in the adoption of leveraging detector-based systems. So, looking at detector-based systems, have you installed them system-wide? Put them out in a few intersections and corridors to test? Are you haven't yet, but you're planning on doing some of these things? And then the last option is no, we haven't done it. If it's complicated, feel free to enter your response in the chat. We'd love to hear why it's complicated from leveraging detector-based SPM systems. So it looks like the leaders in the clubhouse here, 37% say yes with a few intersections and corridors. About 30% are no, we haven't, with 21% saying no, but we're planning, and then 11% saying yes, system-wide, and then 4% are it's complicated. So, really good information, but it looks like a lot of folks are in the testing area of deploying at a few intersections and seeing what else can happen here. So with that, I think I'm going to turn it over to Sean here to talk about some of the GPS-based use cases.
Excellent. Thanks, Steve. Thumbs up. Can you see my screen, or are you seeing the right screen? So I've just switched to a dual monitor system. I'll make sure I'm showing the right screen.
Yes, and yes.
All right, excellent. So I'm going to talk you through these use cases. The vast majority are going to come from my experiences the last 5 years as the county traffic signal engineer in Washington County, Oregon. We're managing 350 traffic signals, over 100 ITS devices, and we have played around with roadside Bluetooth readers. We had those kind of system-wide, so I understand the illustrations that Steve was providing relative to sample size and data stacking. It's not just SPM trajectory-based data. That also applies to Bluetooth Wi-Fi readers or any other probe data set where you don't have a full measure of the population. But yeah, I'm going to walk through a couple use case applications. These examples all happen to come from INRIX Signal Analytics. So you're going to see some of the visualizations from INRIX Signal Analytics. The ATSPMs and other products out there are probably doing something very similar. So keep that in mind. So just as a matter of getting oriented to the daily email, which is a component of the subscription to the INRIX Signal Analytics platform, that we found really useful, and some of the use cases are derived from this, because that daily email was a nice way at a 30-second snapshot to be able to look and see, is my intersections, are they normal or are they abnormal? And then we could ask ourselves the question of, do we know why they're abnormal? And kind of thinking through that. So let me get you oriented to this. So hopefully you guys can see my mouse. This kind of looks at what that daily email looks like. So you're going to get information that tells you which day corresponds to the information, number of intersections in the license, the overall trajectory of overall control delay across those intersections. And then really what's useful for us on the agency side, I thought, was this comparison of where has control delay gotten worse relative to a 4-week normal. And so what you see are the intersections listed as kind of the top 5. That 4-week rolling average of what's typical for a control delay or control delay per vehicle. And then that individual day where we're seeing a spike or an increase in delay. The absolute change in that delay increase, and then the percent change, which I have circled in red here to show you kind of what's going on. And then we do the same thing for corridors. So getting some information about where's travel time getting worse, relative to normal, or the 4-week rolling average? And then where's that travel time index or reliability? Where is that getting worse compared to the 4-week rolling average? What you'll find in some of your data sets is that, like Steve showed, the single day has some noise to it. So what we found is anytime that these percentages were 30% or less, that typically corresponded to the noise that was in the system. So when I pulled up my email and saw something like this, I was pretty happy. The worst increasing delays for that day were within the bounds of relatively noise. We kind of discovered this through kind of trial and error and looking at our different systems and feedback mechanisms to figure out what was going on with our system. But then we'd have other days like this location where you'd have a spike. In this case, this intersection spiking up 85% from normal, and sending my signal techs out to take a look at it and finding out that it was a bad video image processing card, so our video detection was in recall for an entire approach. So that through and left turn were in recall, which led to this spike in delay. So this is acting as sort of an early warning sign that something's not normal. And then you have other situations like this. This happens to be from this year's 4th of July, where you have a spike of 105%, but the intersection actually feeds to the minor league baseball stadium and the fireworks show that happened, and some of the event planning that likely went on is the reason why this has spiked up. So construction, events, lane closures, these are things you're gonna know about. And so they'll spike up, but you'll be able to say, oh yeah, I know why that's happening. So the series of use cases I'm gonna show are more geared towards those situations where, that wasn't supposed to happen, or I didn't think we'd have a spike in delay. And so this shows immediately after last Thanksgiving on one of our adaptive corridors, where it looks like for 6 days in a row, we had more than a 38% increase in delay. It was spilling back into this intersection from upstream intersection. So sent the signal techs out to take a look at it. The problem wasn't at this intersection, 12 and Sherwood and Martinazzi. It was actually upstream at the next signal where the comm had gone down. So for those of you that are familiar with coordinated systems or adaptive systems, if you've got an intersection that's offline and doing its own thing in the middle of the system, you're gonna have some breakdowns and spikes and delay up and downstream of it. So that's what the system was able to show us with this GPS-based trajectory data. As delay's getting worse, then we get to go figure out why is delay getting worse. Same way here, delay spikes up at this intersection, shouldn't be spiking up. Nothing that we knew about as far as schedule out here. Sent the signal tech out to look at it and found a hung-up loop card. So that's a pretty typical thing, I would say, with the Pareto 80-20 rule. A lot of our trouble calls that we were getting at the county were related to detection. And so whatever tools we can have in our toolbox to help us find those detector issues quicker, preferably before the public finds them and can complain to us or to our bosses, that's even better. A couple other kind of use cases that we found. We had more than one location where contractor was not supposed to hit the detection during this phase of the construction, and detection spiked up at the intersection, and send an inspector out there or a signal tech to look at it, and sure enough, they hit the detection. So then it's at least a proactive way for us to work with the contractor to get that fixed as fast as we can. Gives us a record of what the impact was, and it helps us with setting up future contracts with construction projects and what we want to allow for downtime on detection, or incentives or penalties if there is detection that happens to be hit. This was kind of a neat use case. So quantifying the value of detection. So this was an adaptive corridor where we were switching the detection over to support the adaptive system that we were putting out. And so for a few days, we actually had to have the signals running in recall. So this provided kind of a unique opportunity for us to compare what the typical 4-week previous rolling average for that day was compared to the actual running in recall. And so now the county could tell folks pretty definitively the range is probably somewhere between 50% and 200% as far as your net increase in delay and emissions and all those things that go along with driver frustration when we don't have our signal systems running in the most efficient manner. So again, this gives us some numbers to go back to talk through this. You know, in sort of a unique fashion, we wouldn't want to let our signals run in recall unless there was a good reason for it. Moving on from kind of those traffic signal management applications to more of a traffic analysis, which is what a lot of our consulting folks that may be on the call are going to be interested in, or you know, analysts within agencies. You know, how do I use this data to get from noise to signal? What's meaningful information out of this? So one of the questions we asked ourselves is, I wonder month to month what intersections are having the most split failures. So that's what this chart is you'll see intersections listed on the left-hand side, the approach and movement. So you get very detailed down to the movement level with signal performance measures. And month to month, which intersections are showing up in the top 10 and how often are they showing up in the top 10? And so a couple of these, Pacific Highway and Fallenshire Road, they're showing up multiple times. There's a big construction project out there. Actually, that was one of the examples I just showed where a contractor hit the detection, which may have made things even worse out there. But we know that the congestion's there. We're in the process of trying to fix it. What you're really looking for with this are places where, I didn't really expect that to have so many split failures relative to the rest of the network. And so one example here was Cornell and Murray, where it was that kind of, that intersection's running free, so it really shouldn't struggle with split failures. So we wanted to look at it based on a specific time of day, so looking at it from 5 a.m. to 9 p.m., so really focused on that kind of specific time period in certain days of the week. And so within at least INRIX's tool, there is their native signal analytics, and then a link to the signal analytics that runs through the RIDIF platform from the University of Maryland's CAT lab. So this allowed us to do some very specific time periods, looking at this intersection to judge what's happening a few weeks before, just to confirm, okay, are we seeing split failures longitudinally or across time at this location? We saw 39 split failures for that left turn, and you can see, looking down here, none of the other movements have a lot of split failures, and so this is kind of that balancing act we as signal timers have to ask ourselves with, well, if I've got split failures where people have to wait through more than one green light, can I take time from other movements without creating or moving a problem somewhere else? So this location had to do with a lot of growth, both retail and residential east of the intersection. And then that left turn that comes off of here to connect to the freeway is what's driving this. So this is the signal timing need that popped up due to growth. And so we went through and looked at it in the field. We pulled up some cameras and watched it for, a couple time periods and said, yep, it's not every cycle that we're having split failures, but it's happening enough. And there's enough space at the intersection to try to go ahead and shift some time around. So we gave that left turn an extra 10 seconds of time, noted it in our central system based on the INRIX IQ data, and then went through and looked at a few weeks after as well in INRIX. We also immediately watched the cameras to see, yep, it looks like a lot of those split failures that were occasionally happening are no longer happening. So again, just signal timing on the fly. Instead of putting this into a synchro model and running the optimize function, we're watching it and seeing if it's doing what we think it should do, and then looking at the database for AT-SPMs or trajectory-based SPMs to figure out, is the problem fixed or do we remove the problem? And in this case, we did. We addressed the problem. We only have 3 in the 2 weeks after. We've got a few split failures that are happening here, but it looks relatively balanced compared to the other movements. That's what we were trying to do with our signal timing there at the county. This is another use case. So signal performance measures can help us fix problems on the fly, but we're still going to get trouble calls to come in. This was a trouble call that said that they were waiting longer on the arterial than it took them their full freeway trip to get home. The arterial was less than 1 mile and their freeway trip was about 8 miles. So something we wanted to look into. Sure enough, it wasn't every day, but most days during the PM peak, we were seeing spillbacks down the hill and around the curve, almost to Interstate 5. So certainly we don't want arterial spilling back on the high-speed interstates. So had to hop out there and look at this pretty closely. We were able to kind of assess using some SPM data before to look kind of day to day what movements are struggling. And certainly this confirmed what we were seeing in the cameras, that southbound through, southbound left, and the westbound left were kind of our critical movements. And so travel patterns had changed in the corridor from when it was built. We went ahead and made some timing changes to set the intersections free and do some smarter things with the flashing yellow arrows that were out there. And we're able to assess, obviously in the field, you watch it and you say that feels better, it looks better. But the nice thing with something like GPS-based signal analytics is we could look and definitively say day to day for a few weeks or even multiple weeks, what's happening definitively. And this showed about a 30% reduction in control delay. And that's a real measured control delay rather than a modeled control delay in something like Synchro that's based on approximate counts. And then we could even relate that to energy and sort of green metrics to be able to tell a different story. So in the subtitle here is a link to INRIX's green calculator. So this was helpful for us to not just present the results and, oh, we're helping cars move, but we're also saving people money as far as gallons of gas. And we're also helping the environment in less wasted time out there with maybe a less efficient signal phasing and timing plan. So saving over 22 tons of CO2 equivalents over the year based on the simple signal timing change. So again, another way to message what we're trying to do with proactive signal management. So Len, if you're still there, let's pull up poll question 3 and see if we can get some feedback from our audience. So the poll question here is your agency interested in learning more about GPS-based SPMs? Yes, no, or other. And if it's other, please do put your response in the chat, trying to figure out how to gauge more, how to get more information effectively to the folks that are interested. Looks like we've got almost 40% of the folks that have voted. And again, we've got a vote up on screen. Poll is open right now, and looks like we've got about 79% saying yes so far, 12% no, and 9% other. And please do put a response in the chat there. Cool, well, we'll leave that open. Instead of handing this off, Steve, you want to just kind of talk through these next few slides and taking us home?
Yeah. Actually, I'll take control of the screen for a minute, just so.
Okay, go for it.
Share my screen. Make sure everybody can see my screen. Screen check, yep. Sean. Okay.
We can see it.
Awesome. So yeah, Sean, thanks. I mean, great use cases for SPM, our GPS-based SPMs. I think another element that I think even the detector-based ATSPM systems haven't quite gotten to yet, and I think is something that as we've been going through and doing some of these stacking exercises, we're learning more and more about, and really about the benefits and the different stories you can tell with daily, weekly, and monthly reporting. So as opposed to looking at a single day, which is really valuable for operations. I think a lot of the use cases that Sean was presenting with emails and understanding when a loop got cut, and understanding when there was a sudden change, special event type stuff, whether it's the fireworks at a baseball game or a tailgate for a football game. The daily use cases are certainly there, and certainly can tell a cool story. I know back in my grad school days, we did a lot of before and after studies. And when we were looking at before and after studies, we never knew if we were picking a representative day or not, if we picked a single day. So we really liked to look at weekly. So we looked at a week before we did a retiming and a week after we did a retiming. So the power of a weekly report is really powerful. And then monthly is really nice to get trends and kind of executive level performance measures. So if you're wondering or trying to understand where significant changes are happening month to month, whether it's a signal system degrading just a little bit, maybe it's not a sudden event, but it's a consistent increase in volume, or if it's a seasonal adjustment that maybe we've been looking at a few different reports recently where the huge difference in performance of signals from when school is in session to when school is out of session. Obviously, there's volume changes and dynamic changes to the network that are causing potential opportunities for some improvements to be made on the network. So the pictures on the right there are actually of Austin. This is a single day. It's St. Patrick's Day, March 17th. During South by Southwest in Austin, you can see a lot of red, which is indicating a significant difference from the previous 4-week average. And you look at a week later, tells a different story, right? There's a lot of gray and some green that's showing that a week later this single day was different. You can tell different stories with a weekly and a daily and weekly and a monthly report. One of the benefits of being able to have kind of all of this data in the cloud at your fingertips, and also the ability to look system-wide without leveraging, without having to have detection structure in place. You can kind of look system-wide and understand these daily, weekly, and monthly use cases. So just wanted to kind of throw that out there. I think this is a place the industry is moving to get kind of the higher level daily, weekly, monthly assessments, and it's something that we've been noticing, and certainly there's some power and different and storytelling ability with the different types of reports. So finally, and then I'll open it up to questions. I think Sean and I did a pretty good job of keeping us on time today. Really the conclusion is monitoring the performance of signal intersections is beneficial for quite a variety of reasons, whether it's real-time operations, whether it's proactive signal management, whether it's before and after studies, whether it's identifying areas where you need to invest more, whether that's in permanent infrastructure, or whether that's in standard signal retiming processes. I think there's been a number of papers and journal articles and research reports. The one on the right here is a recent FHWA report showing kind of around the country folks who have installed detector-based SPM systems are realizing real measured benefits from a user cost perspective. So there are benefits involved in these SPMs. One thing that I love, and I think Sean does a really good job of as well, is telling stories with the data to help understand both what your team or what your agency is doing, and how we're actually making folks' lives better by improving signal timing, reducing delay, and others. So telling stories with the data is really powerful. We know this is the direction that a lot of agencies across the country are moving. The pitch here is that we do think that GPS-based system can help expedite this process. Going from waiting to install detection or communication at every single intersection to being able to kind of at the flip of a switch turn on an entire network and really kind of realize the performance measure benefit right away. So I think the GPS-based systems are really going to help expedite this adoption of signal performance measures. It's something that I know I'm really excited about. I know I've had conversations with Sean, and Sean is really excited about it. I think a lot of us at Inrix are also really excited about the potential of signal performance measures and pushing the state of signal performance measures forward. So that's kind of the conclusion here. Hopefully you learned something new related to use cases and benefits of signal performance measures. I will just do a quick plug before we get to the questions. And this is the plug for the questions, is if you have any questions, feel free to use the question box now. And Sean, Ted's going to MC, but Sean and I will be happy to answer them. So if you have any questions, feel free to ask them in the question box. But we are going to plug our next section of the series, which is Signal Performance Measures 301. Sean, I don't know if we're allowed to unveil our other speaker, but we're going to try to bring in a few other speakers for this this adaptive signal control session, but we do think, talking about how SPMs relate to adaptive systems, including evaluating adaptive systems with SPMs and scoping systems and before and after studies using signal performance measures at adaptive systems is a rich area for a discussion and a presentation and some expertise from folks who have gone through this. So mark your calendars for September 14th. That's a Wednesday, noon, same time as this webinar, and we'll be excited to talk to you then. So with that, thank you everyone. If you're interested in hearing more about the signal analytics offering that INRIX has, we didn't really kind of go through menu by menu, but if you're interested in that, feel free to check out the website there or shoot Sean or myself an email, and we'll happy to get in touch and talk through and show you a demo of what our GPS-based module looks like. And with that, I'll open it up to questions in the question box. And Sean, if you have anything to add, let me know.
Now we've got 4 minutes, so let's see if we can get to some of these. Ted, I don't know if you've got some queued up that we can talk through. I can't see the questions very well in my chat box, so.
I do have one good question that just came in here that asks, are you aware of any effort to integrate detection-based and GPS data to leverage the benefit of both?
Yeah, it's a good question. I think it's something that is out there as far as a concept. I have not seen yet, and maybe Steve or Ted, you can comment on this, but I haven't seen anybody in the marketplace that's integrated both.
I think, yeah, so we've got some clients that are doing this, right? So there's a lot of discussion of people adding what we call a virtual infrastructure layer to their system, right? So even if you're heavily invested in detector-based ATSPMs, and everybody knows you need some level of detection for operations of signals, when the cost of the GPS-based systems are so low, it's essentially the cost of adding a single additional detector to an intersection. In order to get this ubiquitous apples-to-apples data layer across the entire system, there's value in adding that even if you have detector-based systems in place, because it's so rare that detector-based systems are set up to have detection, especially on the side street, to give you this apples-to-apples data set across the system. So one of our longest, users of the platform, like the City of Austin, that Steve pointed out, has a central system with detector-based information as well, right? But for system-wide performance measures, you can get actually better information from the GPS data, again, because you get this apples-to-apples data set everywhere. So I do see that coming, and we're getting more and more clients doing that. And so I really think that holds a lot of promise. So folks really fall into a couple of categories. So one's where they really don't have the resources to do detector-based ATSPMs or central systems, where this does provide good visibility and a lot of utility. And those that do have those systems, but just want to add this extra layer of information and value. So I don't know, Steve, if you want to add anything onto that.
No, I think that was well put.
Okay, cool. So next question is about recording of the webinar being available. And so yes, everybody will get a link following the webinar that, or get an email that includes a link to the recording. And it is something that you can share with others in your organization as well. And you can always go to our website to also find links to past webinars. Let's see. Most of the other questions were kind of one-on-one that I've answered, so we'll just kind of throw it out. We're getting quite close to our last minute anyway. So anybody has a final question they want to put in the question box, go ahead and throw it in there now. Okay, Sean, Steve, I'm not seeing anything, so I don't know if we want to do a wrap up.
Yeah, let's wrap it up. Thank you, Ted, for moderating the Q&A and getting some of those detailed questions out to folks. Sure appreciate everybody sticking around till the end of this conversation. Hopefully you learned something, and I'd encourage you to check out the recording of the webinar if you want to see the slide deck and get some more information. And you know, feel free, like Steve said, to reach out to him or I or Ted, and we're happy to have a conversation and show you a little bit more about what we have going on here at INRIX. But hopefully this was useful from a overall perspective of where the industry's at. Steve, anything else to wrap up with?
I think you summarized it well. Feel free to email us. Love responding to folks and talking about this stuff. I know Sean and myself and Ted, are all three of us are incredibly passionate about signals and signal performance measures and all things signals. So just let us know if you have questions, and we're happy to talk.
Yep, at the end of the day, it's about better mobility and safety for our users and making your job easier and better. And that's what technology should enable, and that's what we're hoping to get out of both the detector-based and GPS-based solutions. So well put, Steve. And with that, I think we can wrap up. Thanks, everyone.
Thanks all.